My name is Michel Cornily. I'm working for Orange, and I'm also the vice chairman of 3GPP SA5. So this presentation will be done on behalf of 3GPP SA5, actually, or let's say on behalf of 3GPP as a whole. And the goal is to try to explain you what we are willing to do with regard to the integration of our management framework for the management of 5G networks together with ONAP. So our expectation in 3GPP is to be able to specify how to integrate what we are specifying today as kind of, could be called northbound interfaces, let's say, and how to integrate this with ONAP kind of southbound interfaces. You know, we need to plug them together. So today we have already northbound interfaces in a way, but they cannot be interoperable, so we need to do something for that. Otherwise, there will not be interoperability between the two. And of course, for operators, it would be a big drawback. So what we expect is that ONAP and 3GPP work together to complement each other, but not overlap. So the content of my presentation will be a rapid description of 3GPP, very rapid, because on the very first day, Thomas Tovinger from Ericsson already gave a description of 3GPP. Then I will describe the 3GPP management framework, kind of quickly also, I think. And then I will come to the core of the presentation, which is the integration of these two worlds. The first sub-bullet is about positioning these two. And then we'll go to FM, I mean fault management, performance management, and then configuration management, how we can plug them all together. So quickly, the 3GPP structure. On the left-hand side, we have a number of working groups which are in charge of specifying all RAN aspects. So, you know, all the protocols at layer 1, layer 2, layer 3, end-to-end, I would say. So this is very complex. In the middle, you have the technical specification group CT, core and terminal. These guys specify the protocols which are at the core network and also end-to-end network. I would say from layer 3 or layer 4 to upstairs. And on the right-hand side, you have the technical specification group SA, which is for system aspects. So these ones specify requirements for 5G, for instance, and also architecture of the 5G core network. And then you can discover here the SA5, which is here, which is located here, but in fact, SA5 is in charge of working on specifying management interfaces for the whole 3GPP network, end-to-end. 3GPP releases, okay, we are now, for most of the working groups, we are in the release 16 until the end of this year. And there is also already, always some delay between the working groups because, of course, those working groups which are working on high-level requirements, they start their release earlier. And some working groups which are working on producing, for instance, ASN.1 specifications, of course, they come at the end of the release because they need input to do that. So there is a shift. With regard to the SA5 scope of work, we are addressing both the radio access network and the core network. And depending on the cases, we have also some application functions or application servers which are in scope. And this applies for both 2G, 3G, 4G, and now 5G as well, of course. Right. Okay. 3GPP management concepts. Okay, we have a methodology which is based on 3 stages. The first stage, or stage 1 here, is about describing concepts, if needed. Sometimes it's not needed if there is no new concept. Concepts, use cases, and requirements. So this comes generally from operator use cases and requirements, and this is written in, I would say, plain English. Okay, and we tend to think that these are more stable. Once they are specified, they don't evolve a lot during the lifetime of the release, you know. And then we have a stage 2, which is derived from stage 1, which builds a kind of architecture or information model, but this is protocol neutral, you know. So for instance, we have some UML description together with some structured English description of what kind of entities we are manipulating and what kind of management services we are going to offer through our interfaces. And then comes the stage 3, which is about protocol specific, what we call solution sets, whatever the name is. So we can produce protocol specific solution sets based on REST, for instance, with JSON payload, but we have also some young models which would be manipulated through netconf, for instance, and so on. So this approach, on a 3-stage approach, is quite interesting. I mean, at least for operators, from operators' point of view, it is interesting because, for instance, when we issue an RFQ for sourcing, let's say, a new 5G network, we ask compliance to each of these stages, you know. So, for instance, if a supplier applies to an RFQ with compliance to all the 3 stages, fine. Probably the integration cost will be very, very low because everything is conformant to the specs, to the standards. But it may happen, for instance, that the stage 3 is not conformant to the 3GPP stage 3. Their stage 3, the vendor stage 3, is different. Why? Because they have selected another protocol, for instance. Okay, so done. So then it means that we will have some protocol adaptation, for instance, to do, and we can know in advance that we will have some integration costs. Okay, it won't be so much because protocol adaptation, we all know how to do that, but okay. But worse, I would say, is that, for instance, if a vendor answers an RFQ saying, okay, we are not manipulating the same information model. Stage 2 is not conformant, you know. So that means, okay, the effort for integration, their solution will be much complicated because they are manipulating things that we don't manipulate in our information system. So there will be a kind of work to make all these map together, which will be more important than just protocol conversion. And then one step further, if the stage 1 is not, their stage 1 is not compliant, I mean, if they are not fulfilling some requirements that we have, some features are not supported, it's even worse. That means their solution will be hardly integratable, I would say, integrated in our old solution. So this is very important and useful for operators. And 3GPP applies this 3-stage approach to 2 things which are orthogonal, I would say. We apply this to describing our network resource models, meaning what we are managing. We have a network resource model, for instance, for 2G network, radio, core, another one for 3G, radio, core, and so on and so on. Same for 5G, of course. And I would say, orthogonally to that, we define management services, which are more kind of FCAPS things, you know. So management services mean, for instance, configuration management capabilities, fault management capabilities, and so on. And these are defined orthogonally to the network resource model in a way that you can reuse the same management services and apply them to different network resource models. So once we have defined these management services, more or less it's quite sure that they will apply to 6G network resource model when it comes. Okay, so we offer some more flexibility using this. With regard to the 5G network resource model, I just copied here some fragments from our technical specification in 3GPP, you know, just to show that a 5G network may be very complex, actually. There are some concepts which didn't exist in previous technologies. So now we have possibility to have standalone deployment, non-standalone deployment, depending on whether you have a core network which is 4G or 5G. You can have single or dual connectivity, depending on whether your UEs will be connected to 4G or to 5G or both at the same time. We know that a new RAN, for instance, a new 5G RAN can be completely disaggregated or not. So there are several options here. non-split, 2-split, 3-split. We know also that the 5G core network now is service-based instead of, as we had in the past, it was reference point-based. And also this new concept of network slicing, which of course we will have to manage. So it brings more complexity in the network resource model of the 5G compared to previous technologies. Now moving to the 5G management services. Okay, we have moved also to service-based architecture. For previous technology, we were more traditional, like everybody does more or less. You know, we had this kind of ITU-T layered architecture where at the bottom we had network elements which were managed by EMSs, and then on top of this we had network management systems and so on and so on. Now moving to service management framework, it means that we are defining management services together with their interfaces, and we don't claim at all, and we are not supposed to say that, which entity in the network will embark or embed these functionalities. It can be a PNF, it can be a VNF, it can be some element management system, if this still exists in the future. Let's see. It can be anywhere. It could be, why not in ONAP somewhere? So we don't want to take any assumption on this. So it will be up to the, let's say, to the vendor or to the solution provider in general to decide, and also to the operator to decide. So we have defined a number of provisioning services, a number of management services for configuration management, for fault management, and for performance management. Okay. So each time we have kind of control services and data report services for each of them. So for instance, for supervision data report services is about sending all kind of alarm notifications upstairs, you know, from the networks up to whatever is willing to consume them. And for the performance assurance, we have two types of reporting services. One is about data file reporting, as usual, I would say, traditional reporting. And a new one, which has been introduced for 5G, is about streaming services. So we are now able to stream because, of course, it's related to some previous discussions, you know. We want to be able to have a closed loop, which is as fast as possible. So we cannot afford anymore waiting for data files coming every 15 minutes or even more, you know. So streaming will be used for that. With regard to the paradigm of communication between a management service consumer and a producer, we have this notion of request and response, but we have also this notion of subscribe and notify, or subscribe, publish, you know. So this is very important. You will see it later. Oops. Okay, now coming to the core of the presentation. How do ONAP and our 3GPP management framework position themselves with respect to each other? Okay, let's see at the bottom here. We have our management services here, which are somewhere in the network, for instance, in PNF, in VNFs, in EMSs, in NMSs, wherever. And these one expose some interfaces. Okay, these interfaces are specified by 3GPP SA5. And what about the consumers? Here on the top, we have the ONAP Release 3 architecture. And we have identified two main components here, which are likely to be the consumers of our management services. The main one is a DCAE. DCAE stands for Data Collection, Analytics, and Events. In the mindset of ONAP, this entity, which is composed of a couple of collectors, these are supposed to collect any kind of events coming from the network. And by the way, not only from the network, but also from the virtualized infrastructure from everywhere. So it's supposed to collect everything. So that means, for instance, that all our alarm notifications coming from the 3GPP network, our performance measurements, all these things will be sent out to some DCAE collectors inside here. Okay, so these DCAE collectors will consume our notifications. And another component of ONAP, which is also important, is the application controller. This one is aimed at being able to configure the network, so the VNFs, the PNFs, and so on. So there are another kind of, let's say, interactions between the APC and those management services, which typically will be provisioning management services. Okay. So, as I said, in the ONAP world, the DCAE collectors are supposed to receive any kind of events. And this is a change with regard to how we are used to work in 3GPP. As I said on the previous slide, in 3GPP we used in the previous releases to work based on subscribe notify paradigm. So everyone, let's say, or every application willing to receive alarm notifications, for instance, from the network, had to subscribe to these notifications, saying, okay, I want to receive this from this network functions, and it was even possible to put some filters. I want to receive only these kind of alarm notification, but not the other ones. Okay, so it was this publish, not subscribe, not publish paradigm which was in place. In ONAP, it doesn't exist. DCAE collects everything. Okay, so it's a big collector, or a set of big collectors. So of course we have to change also our mind here. We have to be able to say, okay, send everything here. Okay, and because this collectors is going to receive anything, each event which it will receive, or even notification, I should say, each message is composed of two parts. There is a common part, which is common to all kind of events, which is called the common event header, and the rest of the message is specific to each kind of event. Okay, we'll see that in next stage. Oops. Okay, yeah, just to say that the ONAP collection framework, it's a kind of incremental also way that they had in ONAP. You know, in their release 1 and release 2, they specified what is called the VES, the VNF event stream. So this is a component of the DCAE, and it was made to receive REST-based message based on HTTP, secure, and with a JSON API. Okay, and they also specified an SNMP trap collector, of course, working with SNMP. In not the last year, more or less the last release on ONAP R3, they also defined the data file collector on purpose to serve 3GPP needs, because that way it was possible to retrieve 3GPP bulk PM files containing performance measurement, okay, in a data file way. And also what they specify now is what they call the VES, so VNF event stream, high volume, because they think that they think in ONAP that a typical REST HTTP JSON API doesn't scale in the real environment when there is, for instance, a lot of performance counters which have to be sent every 10 seconds coming from thousands of virtual network functions in the network going all to the same collector. It doesn't scale. So they have kind of invented a new collector, high volume protocol, which will be based on TCP directly, using TCP directly, and using Google protocol buffer for the payload. You know, so the payload will be binary encoded to be much more efficient. So this is what they have today. Okay, so in this table we try to summarize a little bit what they have in ONAP and what we are going to do in 3GPP for the convergence with them. So on the left-hand side here, you can see that for performance data file reporting, there are two kinds of collectors which are involved in ONAP. The VES JSON collector, just to say, okay, I have a file which is available. You can just go to it and take it. Okay, so it's a very simple notification. And then the data file collector will fetch this file somewhere onto some IP FTP server and will get it. Okay, so no problem. This is done more or less already. And then for performance data streaming for 5G networks, when we have low to medium volume performance data to convey, to send, we can use, we think we can still use a VEST JSON collector. But when it comes that we want really kind of real-time PM data being sent to the VEST collector, we need to go to some high volume real-time thing. So our goal here is not to go for Google protocol buffer, you know, because we are kind of traditional SDO, so we are not going, we prefer to go to TCP as they want, as ONAP is doing, but the payload will be in ASN.1 and will be encoded also. And why ASN.1? Because it's a standard first, and secondly because, you know, the vendors already implement ASN.1 in their base stations. So they know it, the stack is there, so it's a good reuse of what is existing. So the additional cost will be very low. And same for fault supervision. You know, each time you want to send an alarm notification to the ONAP DCAE, there are two ways to do that. In normal conditions, we will use REST HTTP with JSON API. And in case we come to some alarm flooding conditions, we will switch to the other one, which is TCP based with ASN1 encoded inside. ONAP requires to the VNFs which want to, let's say, to interwork with ONAP to be able to switch from one to the other dynamically. So you can move from something which is under normal condition to something which is to be done under alarm flooding conditions dynamically. This is a requirement from ONAP. Okay, subscribe, non-subscribe. I told it already. You know, the DCAE does not support the subscribe mechanism. So that means we have to find another way to say to the VNFs, which are deployed in the network, okay, you have to send your alarm notifications, for instance, to this collector. So this is something that we are going to introduce in our network resource model. So there will be additional attributes which will be attached to the VNFs, as said here, you know, and for each of them, depending on what type of event they are going to send to the DCAE, we will assign a collector IP address to that. And of course, because this is introduced in the network resource model as new attributes, it can be manipulated via the provisioning management services. So this will be set at the instantiation of the VNF or later during the lifetime of the VNF. Okay. As I said, you know, the DCAE will receive any kind of events from the network. So the message that the DCAE will receive, the VEST collector will receive, is composed of two things. The first thing is a common event header, which is common to all kinds of events. And then there are a specific part here, which is depending on each kind of event. So the common event header has fields which have been defined by ONAP. And then you have what they call technology-independent records and technology-specific records, which they have defined already, you know. So for instance, there will be special fields which are dedicated to reporting a fault, some others which are specific to heartbeat, I will explain later, some others which are related to reporting measurements from the network, and so on and so on. syslog data, for instance, and so on. So, okay. And there are some technology-specific records which they already defined also, like for signaling, you know, which this is more dedicated to SIP networks, to, yes, next generation networks, I would say, like IMS network also and things like this. Okay, what we are expecting from ONAP is that they accept us to define our own 3GPP specific record here. So we will ask them to introduce in their OpenAPI spec a new type of event, which is called fraud 3GPP here. And for that, we will define the JSON schema or the OpenAPI schema so that they can use it. So, for instance, this is an example. Of course, it's not specified yet, but this is an example of OpenAPI schema that that will be used by ONAP to integrate our fault notifications from SwiGPP. Something which is interesting is that in ONAP, you know, they can receive our fault notifications if we agree on the previous things. But something which had not been addressed at all by ONAP is how to manage alarms. You know, it's not only to receive them, but then you have to also to manage them. In the real life of people who are supervising the network, okay, they receive alarms, but then they have to handle them. So it goes from, for instance, acknowledging the alarms. Okay, for instance, acknowledging the alarms means that someone, an operator, it doesn't work, right? Is it? Am I already running out of time, or yes? Okay. Oh, interesting. So, yeah, an operator, for instance, can acknowledge an alarm, saying okay to the system and to the whole system, okay, I take it. So now it's my responsibility. You are aware of that, and I'm going to fix the issue. So, you know, if this is said by an operator, it has to be reflected to the other management systems, and they need to be aware of that. And also, for instance, it may happen that the consumer of alarms may realize that, okay, I receive, for instance, alarm notification number 10, and the last one I received was number 1 from the same NE on network functions. It means probably something has been lost in between. So it can issue a get alarm list to resynchronize between the two systems, you know. All this has not been addressed at all by ONAP, so this is something that we have also to work on with them. Okay, I have to speed up then. Heartbeat. Heartbeat is an interesting functionality in ONAP, which enables a DCAE, you know, the collector of the events, not to ping the network functions to be sure that they are still alive. So it's something which is configured in the network functions, and it's a kind of a periodic counter. So periodically, each XNF, each PNF or VNF, has to send a heartbeat message to the DCAE saying, okay, I'm still alive. Okay, I'm still alive. Every, whatever, 15 minutes, 1 hour, 2 hours. And this is something which we are going also to implement in our 3GPP specification for the purpose of ONAP. Okay, so I think I mentioned this already. We'll try to speed up a bit. Okay.
We're basically out of time.
Eh?
Can you wrap up because we're out of time?
Okay, okay, yeah. Okay, so we are going to propose to ONAP to do the same for performance management data. So they can receive performance measurements. So we'll ask them to introduce a new specific record here, and we will provide the corresponding OpenAPI specification. So they just have to refer to it. They don't have to specify it for us. Okay, let me go. For provisioning services, okay, these services are not consumed by the DCAE such, but rather by the APSI, which is another component of ONAP, you know. And this is planned to be done by using the young MIB and together with a netconf protocol. So our 5G network resource model is already specified as a young MIB. We just have to specify how or what kind of netconf primitives are going to be used. And okay, just to make sure that we can interwork together, we are going to propose to 3GPP as a whole to create some publicly accessible folder where we will put all our OpenAPI specs so that ONAP can just, you know, refer to them through public URL, and that's it. So there will be no gap in between. And some useful links if people want to know more about what we are doing. And thank you. Sorry if I'm...